Okay guys, we're beginning a new unit here today, Unit 6. We're still dealing with trigonometric functions, and in 6.1 our topic is going to be trigonometric functions on the unit circle. Okay, so we mentioned the unit circle last unit, but we did not really use it very much, but in this section we're going to use it quite a bit. So the unit circle, what is it? Well, the unit circle is a circle that's given by this equation. And so this equation yields a circle that is at whose center is at the origin and whose radius is 1. So the unit circle centered at the origin, radius is 1. So this is the unit circle. So these 4 points would be on the unit circle: 1, 0, 0, 1, negative 1, 0, 0, negative 1, as well as a variety of other points on the circle, right? But these are the main ones that are on the axes. Okay? Now, let's get a little bit more in depth as to why the unit circle is going to be useful for us when going through and looking at this unit. Alright, so here's what we want you to visualize. Imagine that a real number line is wrapped around this unit circle, okay, with positive numbers corresponding to a clockwise wrapping and negative numbers corresponding to a clockwise wrapping. And I may have said that backwards. I can't remember if I did or not. But it's counterclockwise for positive, and going clockwise is negative, all right, as shown right here. Okay? And so kind of what we have here then is, as the real number line is wrapped around this circle, okay, then each real number designated as t corresponds to a point that's on this circle. All right, so the x-coordinate, the y-coordinate. Okay, so every time that you've got a point that's on this circle somewhere, that x-y coordinate corresponds to a length t. Okay, so that's what we're saying. Okay, so if you stop here, that would have a certain length t. For this ordered pair would have a different number, this ordered pair, and so on and so forth. And then same thing if you went clockwise, the negative direction around it. Okay, so if you're going this way around it, counterclockwise, your t is going to have a positive value greater than 0. If you go counterclockwise around the unit circle, then your t is going to have a negative value because you're going negatively around the circle. Okay, now here's the next thing that we want to make sure that we make our connection on. Okay, so like for example, the real number 0 corresponds to the point 1, 0, right? So right here, okay, there is no, it starts from this x-axis and then comes around this way. So at the point 1, 0, you haven't made any movement yet. Does that make sense? All right, so the real number 0 corresponds to that point. That's your starting point. Okay, now here's the next point. Because the unit circle has a circumference of 2 pi, the real number 2 pi also corresponds to the point 1, 0. So again, once you've gone all the way around 2 pi, you're back at that same point 1, 0. Right? So 0 is associated with this point 1, 0, and then all the way around 2 pi is also associated with this point 1, 0. Okay? Then there'll be different values in between, but every value corresponds to a certain point on the unit circle, an ordered pair on the unit circle. Okay, now, here's the other key point to make sure that we understand, and I know this is, we haven't wrapped up this idea yet, so you might still be asking yourself, well, what are you talking about, Coach? So here's the next point. Okay, so in general, each real number t also corresponds to a central angle in standard position whose radian measure is t. All right? And then, of course, that comes from the arc length formula, right? And it indicates that the real number t is the length of the arc that's intercepted by the central angle in radians. So what we're saying here is this. Okay? Whatever this arc length number is, right, it will match this central angle in radians. So in other words, all the way around, that's an arc length of 2 pi. Okay, well, it's also a central angle radian measure of 2 pi. All right? If I come up to here, and this is a arc length of, let's see, what would it be? Pi over 2. Then this central angle would also be pi over 2. Pi over 2 matches 90 degrees. Pi over 2 radians matches 90 degrees, and so on. All right? So the key point to remember here is when you're going around this unit circle, and each point has a value of t, which matches the radian measure of the central angle, and it corresponds to an ordered pair, an xy ordered pair. All right? And the key thing to remember is that arc length is going to match that central angle because the radius is 1. That's the reason why. All right? So let me give you some more things that will kind of drive this idea home. Okay, let's look on the other page. Okay, so what we've got right here now is we've got the trigonometric functions, and instead of them being defined in terms of a right triangle, the sides of a right triangle where we have opposite, adjacent, and hypotenuse. Because remember, in the last unit we looked at and defined the trigonometric functions in terms of the opposite side, the adjacent side, and the hypotenuse of a right triangle. Well, here we've got the trigonometric functions defined in terms of their corresponding point, the coordinates of their corresponding point on the unit circle. All right? So here's what I mean by that. Like, for example, what we learned last time is that the sine of the angle equals to opposite over hypotenuse. Well, here the equation, when it's defined in terms of the point on the unit circle, the coordinates of the point on the unit circle, the equation is sine t equals y. Well, how come it's different? What happened to the angle equals to opposite over hypotenuse? Well, I'm going to show you how the formula has been transformed. All right, so take a look at this unit circle. So let's say I have a point right here on the unit circle. Its coordinate would be x comma y, whatever they are. This length would be the x coordinate. This length would be the y coordinate. The hypotenuse is always going to be 1 because it's the unit circle, radius of 1. All right? Now, remember what the sine formula that we've already learned is? So if I'm looking for this central angle, sine is opposite. Well, what's the opposite value here? It's going to be y over the hypotenuse. Well, what's the hypotenuse? 1. Well, what does y over 1 equal to? Equals to y. So remember, sine of t, and t is going to be your angle measure, right? It's going to be the arc length, but it also corresponds to the central angle measure, right? So the sine of angle t, right, is going to be equal to y, because the opposite over the hypotenuse in this right triangle is going to be y over 1, and y over 1 equals y, and thus the new formula, sine t equals to y. Okay? Same thing with cosine. What was cosine? Cosine was adjacent over hypotenuse, which is x over 1, which is x. What was tangent? Opposite over adjacent, which is y over x. And then that's where that comes from. Remember, what was a cosecant? Cosecant was hypotenuse over opposite, which in this case is 1 over y. What was secant? Secant was hypotenuse over adjacent, which is 1 over x. What was cotangent? Cotangent was adjacent over opposite, which is x over y. Okay, so these formulas, okay, are just rewritten in terms of the coordinate of the point on the unit circle. Okay, so these are the same principle as the formulas that we'd already learned with opposite, adjacent, and hypotenuse. They're just rewritten in terms of the coordinates x, y, and the hypotenuse 1 for the radius of the unit circle. So that's where these formulas now come from. All right, that's where these formulas now come from. Okay, so the only restrictions here is, of course, any number in the denominator cannot be 0, or it would be undefined for that particular value. All right, and we'll talk a little more about that. Okay, so now, before we actually go into problems, let me show you how that relates to the unit circle. Okay, the unit circle has key degree measures and points on here, okay, that make it easier for us to determine the trigonometric value at that point. So, like for example, you will have this point on here, 0 degrees, all right, and that point is 1, 0. At 30 degrees or pi over 6, so you've got the degree measure, you've got the radian measure, and then you've got the corresponding ordered pair of the point on the unit circle that it corresponds with, right? So at 30 degrees, which is pi over 6, then here are the coordinates of the point. Square root of 3 over 2, comma, 1/2. At 45 degrees, it's square root of 2 over 2, comma, square root of 2 over 2. That would be the length of the x and the length of the y coordinate. At 60 degrees, the ordered pair of the point here, this point would be 1/2, comma, 3 over 2, and so on, all the way around. All right? Then, of course, if you get over to this side, the x coordinates are negative. If you get down here, the x and the y's both are negative, and then so on, all the way around. And then, of course, this point, 1, comma, 0, corresponds with 0 and 2 pi radians, or 0 degrees and 360 degrees. All right? So that's kind of what the unit circle is. Okay? It is a circle of radius 1, and the unit circle has key degree measures and radian measures that correspond to the ordered pair of different points, common angle points, as you go around the circle. So the reason why these are the points that are on here is because these are the most common angles that are used. 0, 30, 45, 60, 90, 120, 135, and so on all the way around. And then we have the matching corresponding radian measure. Pi over 6 is 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60, and so on, all the way around. All right, so this is what the unit circle is, and that's kind of how it's useful for us. So we can very quickly now, by knowing the unit circle and looking at it, we can come up with what the sine of pi over 3 is very quickly by looking at these values. We can come up with the tangent of pi over 3 very quickly by looking at these values, the exact value. As opposed to just putting it into a calculator and getting a decimal number, these are the exact values that we can get. So we can use these coordinates to get the exact values of those trig functions, all right, with these commonly used angles. All right, so that's kind of the purpose of the unit circle. So with that kind of lengthy foundation explanation, okay, laid down for you, we are now ready to actually do some problems using the unit circle. And again, I've put the unit circle at the beginning of this unit as well, so you have it as a reference. Like I say, we just introduced it last unit, but we didn't really use it a whole lot. But in this unit, we are going to use it quite a bit. Okay, now, so again, we have the trig functions defined in terms of the coordinates of the point that it corresponds to on the unit circle. And now we're going to use those formulas in order to answer these questions. All right? So it says to evaluate the 6 trigonometric functions at each number. So the number is t equals pi over 6. Now remember, this number corresponds to two things. This t corresponds to two things. It corresponds to the arc length, right? The arc length going around the circle, okay? And it also corresponds to the central angle. Remember, they match based on the explanation that we had. So at t equals pi over 6, what is the value of all 6 of the trigonometric functions? In other words, what is the value of all 6 trig functions at this angle? Remember, this arc length number is going to match the angle in radians. So we got to find all 6 of them. So the first one is sine. So I want to figure out what sine of pi over 6 is equal to. Well, the sine of pi over 6 should be equal to the y-coordinate, okay, the y-coordinate of the corresponding point on the unit circle at that value. All right, so let's go to pi over 6 on our unit circle. Pi over 6 is 30 degrees. Well, what's the y-coordinate? The y-coordinate is 1/2. So what is sine of pi over 6 equal to? The y-coordinate, which is 1/2. There's your answer. All right. Now, if you don't believe me, then we can double check it on the calculator. So let's pull up the Desmos. Let's go to sine of pi over 6. Oops. And remember, it's defaulted to radians, so we're in good shape. 0.5, and then that is 1/2. All right. So again, we're using the unit circle to come up with all 6 of the trigonometric functions at this number. Okay. All right, so what comes next? We have done sine, we'll do cosine. Let's do the cosine of pi over 6. So we're doing all 6 trigonometric functions of the same angle, the same number value. All right, so cosine of pi over 6 is going to be equal to, all right, so let's see what cosine is equal to. Well, cosine is equal to the x value, all right, at that particular point. So again, we're ready to go back to the unit circle. We're going to look at pi over 6. Then pi over 6 is 30 degrees, and we're looking for the x value. The x value is square root of 3 over 2. So it'll be square root of 3 over 2. So square root of 3 over 2, and that's as simple as the answer gets there. So that is your answer. So the cosine of pi over 6 equals to square root of 3 over 2. Now if we were to take that and put that into a calculator, it would give us a decimal answer. But this is the exact answer. So that's kind of how the unit circle is useful to us. All right, what about next one? We need to find tangent. So let's find the tangent, the value of tangent of pi over 6. All right, so again, what's tangent? Tangent is y over x. Let's go to the unit circle. The unit circle is here. So y over x is going to be 1/2 over square root of 3 over 2. So let's write that in. So the tangent at pi over 6 is going to be 1/2 over square root of 3 over 2. All right. Now, the question is, how do we simplify this expression? Well, remember, when you divide by fractions, that's the same thing as multiplying by the reciprocal. So let's do that first. So I'll flip the bottom and go 2 over square root of 3. Okay. So when I do that now, that has given me, the 2's will cancel, and that leaves me with 1 over square root of 3. Okay, but remember, we don't want to leave a square root in the denominator. We want to rationalize the denominator by multiplying the top and the bottom by square root of 3. Remember, you don't want to leave any square roots in the denominator. It's considered unsimplified. And so when we multiply the top, we've got square root of 3, and square root of 3 times 3 is 3. And the reason why mathematicians typically want to rationalize the denominator is because there's a chance that something will cancel out once you rationalize the denominator. So this is considered the simplified form. That's your answer. So the tangent of pi over 6 is equal to square root of 3 over 3. Once again, by utilizing the unit circle, we can get the exact answer. All right, and we don't have to rely on putting it into a calculator to get a decimal. All right, so there you go. So we've done half of them now. We need to do the other half, don't we? All right. And by the way, I should have written out the point that corresponds to this, which is square root of 3 over 2, comma, 1/2. And that would be so that we don't have to just keep looking back at the unit circle every time. All right. So what do we come to next? We've done tangent. Let's do cosecant. Cosecant of pi over 6. Let's see what that's equal to. All right, so cosecant is equal to 1 over y. It's equal to 1 over y, right? And so since cosecant is equal to 1 over y, then I can just put it as 1 over. Now, what's the y coordinate here? The y coordinate here is 1/2, okay? And equals, to finish that now, 1 divided by 1/2. So that would be 1 over 1. Times the reciprocal of the bottom, 2 over 1. And that's going to be equal to 2. And then so there's your answer. Okay? Now, here's another way that we could have done this problem. Since we had already done sine, and we know that cosecant is the reciprocal of sine, you could have just taken what you've got here and done the reciprocal and known right away that it was 2. Okay, however, you may have problems where it's only asking you for cosecant and you haven't already done the sine portion of it. But that's one way to verify that we have done it correctly. Okay, what else do we need? We need secant. Okay, so we need secant of pi over 6. We want to find the secant of pi over 6. Well, what's secant? It's 1 over x. So it's going to be 1 over, what's the x coordinate? It's square root of 3 over 2, square root of 3 over 2. So that's 1 over 1 times the reciprocal, 2 over the square root of 3. And so now as we go through and multiply that out, just go ahead and do it down here, we'll get, let's see, I need an equal there, not a times. And so now when I go through and multiply that out, that's going to be 2 over the square root of 3. Once again, we've got a denominator we need to rationalize, times square root of 3 times square root of 3, which doesn't change it, by the way, because you're multiplying by 1. And so that's 2 square roots of 3 over square root of 3 times square root of 3 is 3. And so we have the correct answer here. And now, if we were to take this and then match it back to one that we had already looked at up here as far as the reciprocal, now this should be the reciprocal of cosine. All right, and the question is it? Well, what was cosine? Square root of 3 over 2. So if I just flipped that to 2 over the square root of 3, I would be here. And then once I rationalize it, I would be getting back to the answer. So you could also do it that way, because don't forget, these last 3 trigonometric functions are just reciprocals of the first 3. Okay, so likewise with tangent, let's take a look at it. We need cotangent. So cotangent, but I'm still going through it without doing the reciprocal method because, like I say, you may be asked for the cotangent without having to do the tangent first. So you can't just rely on reciprocal all the time. So cotangent, pi over 6, and we're going to make that equal to, let's see what it is. So cotangent is equal to x over y. So the x is square root of 3 over 2 over the y, which is 1/2. Once again, I'm dividing fractions, so I'll have to multiply by the reciprocal, which means I'm going to take square root of 3 over 2 times reciprocal 2 over 1. And so once I have done that now, that is going to make the 2's cancel out. And so that's just going to be square root of 3 over 1, which is square root of 3. And then there is your answer. And of course, likewise, if we had taken this, because remember tangent is the reciprocal of cotangent, so once I flip that, I would get 3 over the square root of 3. And so when you went through and did the, what am I trying to say here, rationalizing the denominator there, that'd be 3 on the bottom and 3 square roots of 3 on the top, right? So the 3's would cancel and leave you with square root of 3. So it works that way as well. It checks out, okay? All right, so again, we've gotten all 6 of the trigonometric functions for the first one. Let's go ahead and do all 6 of the trigonometric functions for the next value, which is negative pi over 3. So where's negative pi over 3 on my chart? So negative pi over 3, okay, would be negative 60 degrees. Okay, so when you guys are looking at this now, negative pi over 3, okay, when you've got the unit circle, it's not listed as negatives, but anytime you've got a negative, what you can do is you can say, okay, where is it here? 1, 2, 3, so I need to go back 1, 2, 3. So it would be there. So negative 60 degrees, 360 minus 60 would put you at 300. So negative pi over 3 is this value right here. So this is the point that we would use. All right, so negative pi over 3 radians hits right here at this point, 1/2 comma negative 3 over 2. So that's the point that we're going to use. It's going to be 1/2 comma negative square root of 3 over 2. All right. And so once again, we're going to have to find all 6 of the trig functions. Let's start with sine and see what we come up with. All right, so I've got the sine of negative pi over 3 is equal to, okay, so remember, sine is equal to y. So what's the y number here? It's just negative square root of 3 over 2, and we're done with that one. Okay? Next one is going to be cosine. We need the cosine of negative pi over 3. And remember, cosine is just the x value, 1/2, and we're done there. Now we need the tangent of negative pi over 3. You want to see what that's equal to. And what's tangent? It's y over x. So what's the y? It was negative square root of 3 over 2. And what was the x? 1/2. Okay. And so from there, to finish that off, then I'll have to multiply by the reciprocal, which is negative square root of 3 over 2, the reciprocal of the denominator, I should say, 2 over 1. So when you go and multiply that out, the 2's will cancel, and then so that's going to leave me with negative square root of 3 over 1, which is negative square root of 3. That's the tangent. Let's go with the cosecant next. So cosecant of negative pi over 3 equals, the cosecant is equal to 1 over y, 1 over y. So the cosecant is going to be equal to 1 over negative square root of 3 over 2, because that's the y coordinate of the point at that number. And so what we'll have to do now at this point is multiply by the reciprocal of the denominator. So that's 1 over 1 for the top number, that's equal, times reciprocal would be 2 over negative square roots of 3. So when I multiply that out, I'll come up with 2 over, let's see, go ahead and make that negative, 2 over square roots of 3. So I'm ready to rationalize the denominator, multiply the top and the bottom by square root of 3. Then we'll come up with negative 2 square roots of 3 over 3. And then so there's your answer. All right. We also need secant. And so for secant, secant of negative pi over 3. And then so what is secant? It's 1 over x. So I'm going to write that as 1 over 1/2. And once again, we'll go 1 over 1 times 2 over 1. And so that just makes 2. All right? Which makes sense because it's the reciprocal of 1/2, which is 2. So we're good there. And let's go to cotangent for the last one. Cotangent of negative pi over 3 is going to be equal to, so our cotangent is x over y. So the x is 1/2. The y is negative square root of 3 over 2. Okay, so let's come in and multiply by the reciprocal of the denominator, which would be 1/2 times negative 2 over square roots of 3. All right. So when I multiply that out, the 2's will cancel out. Then that'll leave me with negative 1 over square root of 3. Now I'm ready to rationalize the denominator, square root of 3 over square root of 3, multiply that. Still negative, positive times a negative. And so that's going to leave me with square root of 3 over 3, which should be the reciprocal of what we got with tangent. Okay, and it is, because if we flip that, right, then we end up with here, and then once you rationalize it, you're back to this one. Okay, so again, on your quiz, it's going to be asking you to find certain trig functions, okay, at a certain value of t, and whichever one that they ask you for, that's how you do it. All right?